And I'm gonna start actually with the boring stuff, with some housekeeping today. So for all of you to know that we are recording this meeting in order to have it be available on our website later on so that others can also learn from this presentation. For the Q&A section, that's going to be a big part of this webinar. We're asking all of you to please rename yourself so that your name appears first name, last name, and then your organization. You do this by clicking on the 3 little dots that you see if you have your video on when you scroll with your cursor over your video. Or you can do that if you click on participants, find your name, and then also click on the 3 little dots or the little arrow that points down, click on rename, and then you can choose whichever name you want. Unfortunately, mine is in German, but I think you still get the idea from the pictures that you see here. And most of you are probably familiar with Zoom by now. Also, it's basically up to you how you want to experience this webinar. So you can have the speakers in big if we don't have a presentation, or you can see everyone who has turned their video on by in the top right corner choosing gallery or speaker view. And for the later portion in this webinar, if you do have questions, which we hope many of you will have, because we want this to be a learning experience and an open discussion, you can either use the little hand raise symbol that you will find on your bottom control panel, or you can write in the chat that you have a question, and then I'll call you by name and ask you to turn on your video and your audio so that you can speak to the entire group and everyone can hear your question. I think that's it in terms of the boring stuff. And now I want to introduce RGI's CEO, Antonella Battaglini, who will say a few welcoming words today. Antonella, the floor is yours.
Thank you very much, Steffi, and welcome to everybody. I would like just to take a few minutes of your time, just remembering that sharing best practice is fundamental to support and accelerate the energy transition. So I'm really glad that Elering is today sharing what they have been doing. Indeed, they did participate in the Good Practices of the Year Award, and it's a pleasure to have them. I would like to remind all the participants that last week the European Council has decided to increase the target for the decarbonization target for 2030 to 55%. Some groups say it's not enough, some others say it's far too much. The reality is that if we really want to combat climate change, we need to accelerate massively deployment of renewables, deployment of grids, electrification, flexibility, and much more. And of course, doing this poses a lot of open questions, a lot of challenges. And I believe that none of us can do it alone. We all need to learn from each other. And in this spirit of sharing and learning, I leave the word to the speakers for this webinar, and I hope that this is a good way to almost end the year in a few days, and then put us on track in restarting this type of conversation in January. So best wishes from my side, also for a healthy and very productive 2021. Thank you.
Thanks a lot, Antonella. For the new people in the room, I just very, very quickly want to say, well, which kind of environment you've put yourself in. So RGI is an association based in Berlin with a considerably unique membership structure. So we're having TSOs, transmission system operators, and NGOs who work on climate and nature on board, who come together under the roof of RGI to work on an energy system for a renewables-based future. And our members come from all over Europe, and we're very excited today to have someone who's a little further east than most of our members. yeah, but in general, we cover quite a big portion of the European countries. So it's always interesting discussions that we have, and always very different perspectives that come together. And specifically, our best practice work is one of the most important things that we do. We collect our best practices mostly via our Good Practice of the Year award, which this year Elering was a part of. And we share them via very many different measures. So we do reports, we showcase them in our database, and we talk about them in webinars such as this today. And I'm very excited that today we're having Elering here and that they're going to present the e-Gridmap, which was one of the practices that our jury was particularly excited about in the award this year. So I'm very interested to learn even more about it, and I hope all of you are as well. Yeah, and without further ado, I want to hand over to our speaker or our speakers. I'm not entirely sure, so we had some technical troubles this morning. But for sure, we have here Oleg Tšernobrovkin, the head of energy system planning at Elering. And we may also have here Alari Heinla, the power system analyst at Elering. We will see whether Alari has actually managed to make it. But for now, I'll hand over to Oleg for his presentation of the e-Gridmap in more detail. And I look forward to a lively discussion and a lot of questions afterwards. Oleg, the floor is yours.
Thank you, Stephanie, and hello, everyone. I'm glad to see so many people from Energy Society from different parts of the system, and welcome. Today I'm going to talk about e-Gridmap. So my name is Oleg Tšernobrovkin, as I was introduced. So a little bit about myself. I'm head of energy system planning unit in Elering. So Elering is a transmission system operator company, and we actually are operators of both gas and electricity system. So this e-Gridmap is about electricity. Before I go to the details, I would like to talk about the story of red button. So I was joining Elering in 2007 as electricity system analyst, and I clearly remember that I was put in charge of doing totally new things for me. So I started to work with PSSC, which is a network calculation and modeling software. And already by that time, I started to make some scripts and code to make this work more simple, to automate some calculations. And then my boss, Mr. Matlandsberg, who is working in Elering today as asset manager. So he told me that, Oleg, you should make such a red button. You just click on it and the computer will do all the work, all the calculations, and you will get the results highlighted, what you actually want to see. And this idea, I think it started to live and has continued through my professional career. And unfortunately, I couldn't manage to finalize this red button myself. But when I became the head of the planning unit myself, and luckily I got some really talented guys in my group, Alari Heinla and also Ilja Matjas. And I think I could give this vision or this idea about this red button to forward it to them. And it continued, and I see that today this red button is ready. So I'm very glad that this work has been continued. But about the e-Gridmap, so we have roughly 1 hour. For 20-25 minutes, I'm going to give you overview, a presentation of this. So I'm talking a little bit about why we were starting to do such project and some experience about it, how it has affected our work. And then I'm also going to talk about the details and algorithms behind this e-Gridmap. And at the final part, I'm also going to open the live version of this tool, and we have some discussion time. So I'm open for all questions and discussions with you to share this experience. So why we decided to do something like e-Gridmap? I think the first idea is to help our clients, to help them to assess their business plans in more effective way. And the second reason was to help ourselves, because of the every year the number of the requests was increasing to connect new renewables and also consumption side connections. The workload was increasing so much. So if we would do the things the same way as we used to, we have to take new people into work, and maybe it's not even enough. So we looked if there are other options, and it looked that the option is to try to automate this process. So this e-Gridmap is a huge help for ourselves to reduce this manual work and working hours of human resource. And during this process, we managed to make this work more efficient, and also the quality of the process have increased, because during this workshops and brainstorming how to automate it, we also faced the need to increase quality of the data of this process in overall. So at the end, we have more quality in our analysis and results. Here is also a graph of latest numbers in connection application and the technical requirement requests by the clients. So you can see that the number of megawatts which is annually asked to be analyzed or to be connected is increased quite a lot. Only one number has decreased. It's the megawatt for technical conditions, because now it's possible for clients to see themselves already the result in web page. And what is also remarkable, that actually the efficiency, which I could call here as a completion rate of the requests going into agreements, is increased significantly. So it seems that this tool helps to focus the client plans and to hit the correct spot, that they can actually realize this in a contract and start to make real developments. So those were the main reasons and also the outcomes. Now, if I continue about the e-Gridmap, it was designed for Estonian power system, and I think I need to give you overview about the connection principles in general in Estonia. So if a client would like to connect either new consumption or new generation into the system, it's basically possible anywhere and any size. It's a question of the costs. And the costs are evaluated such way that the client is responsible of covering the costs which are related to the grid reinforcements, which can eliminate the overloadings that is caused by this same client. And that is why we are doing such grid calculations to find out those impacts and to find also the countermeasures to eliminate these overloadings. And then this is included into this connection fee, which is bounded into the connection agreement. And the measures that are found out how to eliminate the overloadings, it's we try to find the minimum cost to do it. So we are not building the maximum capacity lines and so on. But however, those measures, for example, line reconstructions, new lines, those have to be in line with our technical policy requirements. There are some minimum requirements that, for example, the voltage level of the line, the minimum cross-section of the wires and the design temperature, those need to fit into the system. Otherwise, if we build something very low transmission capacity, it will start to be a bottleneck for future. So it shall be consistent, and this technical policy is coordinating this consistency. And the analyses are deterministic, so it means we get some really concrete values from the grid analysis, and there are some certain limits. And if it's exceeding these limits, then the client need to solve this. If not, then it's okay. So it's N-1 analysis is done on grid network. And the impact which is analyzed is basically the base scenario or base scenarios which we have developed, which are presenting different operational points of the system. Usually those are more extreme, like in regards of export or import, the load, summer peak, winter minimum loads, and different set of generation patterns. Those are mixed, and we found those more critical scenarios, and all those scenarios will be run with and without the new customer. And then we compare the results, and we will find exactly this impact what this new customer is causing, and by this we can evaluate what is a responsible of client to solve. And I also mentioned it's not directly related to this e-Gridmap, but also this flexible connection conditions are possible today. It was not possible a few years ago, but now this option gives client possibility to connect to the grid without doing grid reinforcements. Instead of that, we will apply to the contract those certain overloading conditions that if those appear in real life in system operation, then Elering has right to decrease their output level to some certain degree, which is also defined in this contract. So during this analysis, we actually find those breaking points where different lines can be overloaded, and then those breaking points will be set in this connection agreement. So we call it flexible connection terms. This is also possible today. And about this e-Gridmap, maybe from point of view from the developer, it's a tool for the investment planning. Probably the developer has quite a good understanding what are the expected sales and revenue from the electricity sales, maybe some schemes from government side, subsidy schemes, those all are taken into account. And then from other side are the costs. Probably the investment cost is quite well predictable, and also the operational costs can be assessed. But this part, what is now missing, is the grid connection cost, this gray area here. And this is where e-Gridmap gives you an answer. And this is why this tool was done, to evaluate the quite exact cost, how much a certain megawatt of connecting power to certain substation costs. And a little bit of the process, effective efficiency. So it has really increased our efficiency and decreased the time for calculations. I'm not maybe going too much into details like how it was before and now, but the main difference here is the manual work, that before the client had to apply its request to our client service, and then the client service brought it to the internal in the company to some correct people who was doing the grid analysis manually, and then the initial data had to be maybe specified, and it all which is related to human communication and forwarding the information. Some errors could appear and so on. So it took a few weeks up to maybe 3 months was a maximum time of this work. But now, as it is all automated through this e-Gridmap, it takes a few seconds to minutes. So it's instant basically. And what is going on after that, it is of course the same, that assigning the contracts and conditions, it is still the same way as it was. But actually I can say already today that the goal is to automate also this part, that we get the quality of the results so good that it's possible to actually, based on these automated calculations, to propose already bounding contract. But this is future. Today we will see the so-called preliminary assessment or results, but which are already today quite close to those values which will be put into the contract. And general feedback from or experience from e-Gridmap, now it's now less than 1 year. This e-Gridmap 2.0 has been in operation, and we have great positive feedback from our clients, especially the production side, the production developers. And regarding our internal work, it is also decreased the time which we spend on the certain analysis, and we didn't have to increase our staff. And also, as you see from the graphs in the beginning, this e-Gridmap probably has helped to focus the client targets regarding the location of the connection point and megawatts. So the number of new contracts has increased. Now let's go to the details and algorithms of e-Gridmap. So this is the layout or the view, how you see the e-Gridmap when you open it. You basically get Estonian map, and on top of it there are substations and lines. The purple lines represent 110 kV, and those smaller bubbles are 110 kV substations, and the bigger bubbles are 330 kV substations, and the yellow lines represent 330 kV lines. This is an Estonian transmission system. And before I continue, maybe also a little bit about the history that there was in operation, I think almost 2 years, e-Gridmap 1.0, so the first version of it. And actually it was basically the map with some tools. You could set the limit for the megawatts. And this is showing actually only the value which can be connected without doing any grid reinforcements. So the first breaking point where the client connection capacity is causing some troubles, there the analysis stopped, and the value was given as the first breaking point. And the colors of the substations then represent that if it's red, it's close to zero, the available capacity, and if it's green, then you have plenty of free capacity there. But it doesn't show the client that if I still want to connect, for example, in the western part, I see it's red there, there is not so much free capacity left, but I still want to add, for example, 50 megawatts. So how much it cost for me? With the first version, it was not possible to see, but with the upgrade 2.0, it is available. And it is available because two major analysis parts were combined. First, what was also before there is N-1 contingency analysis. So it's a grid calculation. It's based on PSSC model. So we have Estonian power system modeled in PSSC, and there are several scenarios developed, as I told you before, and the N-1 calculation is done for all the possible scenarios, all the possible substations, and until some certain maximum value. So this maximum value is in 110 kV network it's 100 megawatts, which is automatically calculated, and in 330 kV network it's 300 megawatts. It's because when the capacity go bigger, then usually it requires some new lines to be constructed, and this is not easily, how to say, automated. It needs some human interaction to see where it's actually possible to construct the new lines, and maybe this part is coming in future. That's why this megawatt is limited. And maybe this slide is to represent that this grid analysis is quite comprehensive part of the e-Gridmap, and at the end we end up with 54,000 cases to be analyzed. So on top of those 54,000 cases, each n-1 is calculated, and for each line, each substation, the loading values are exported. And we will get the massive database of the results from there. And this will give us a picture how the line loads react to the certain megawatts added to different substations. And we have a big matrix database where all the values and all the breaking points are defined. And the big part of this e-Gridmap is also the data processing. So if the calculations are done, then with the help of Python scripts, it finds out from this huge amount of data the most critical points and the most critical loadings, which actually define the exact point where some certain line is overloaded. And those will be again filtered out and put in like separate database which are input for the next phase. So this is grid analysis part, and the calculation time is pretty big. So if we make a full calculations for this system, it takes 48 hours. So it's a totally automated calculations, but due to such a big number of cases and data which need to be transferred and then filtered and processed, it takes 48 hours. And here is an example of this result in visual way that we have with a blue scale or blue bars represent the line flow before the new customer is connected, and then the orange lines or bars represent the flow which this additional flows which are caused by the new customer. So this is, for example, in Nova substation, 165 megawatts. And you can see that this client, if it comes to the system, will cause these additional overloadings in quite several lines. Now, with the grid calculation, we have this data, but how much it costs? I think it's even more, let's say, difficult to find out or to agree what is a cost. And our methodology is that we have some list of activities which we have agreed among our maintenance department and also with the technology department, who is responsible for substation, how to expand it, and the line maintenance department is responsible of maintaining and upgrading the existing line. And then they know exactly what kind of options there are. The most usual limiting factor is the line overloading. And most of the, not anymore most, but the older lines which are in Estonian system that are causing this bottleneck are built in the end of Soviet times. They still have some 20 years, 30 years resource left, but they were built with designed wire temperature only 35 degrees Celsius. So it means when you push more current through the line sag will drop down, and it is violating the standard and the safety actually for the human, animals, and plants. So this is the limiting factor. And then there are some activities, and we have evaluated what is the cost of each action. And by this, if we combine this knowledge with the grid results, we can actually find out the necessary works, additional works to be done to achieve this target capacity. And that's how we find the cost. So maybe some explaining picture also about that, what I talked about the line sag, that if the wire gets more loaded, then the wire drops down, and there are some critical height where it can start to be dangerous, and we cannot allow more current through the line. But it's possible to increase it a little bit. It's the cost is rather small. When you want to increase it more, it's the cost is higher. And the last resort is, of course, to reconstruct that totally this line with the new standards, which has very high transmission capacity. And for having this data, then Elering is doing the laser scanning of all our lines, 110 and 330 kV lines. Usually it's done with a helicopter, like flying over the line with a radar scanner, and it's updated in every 5 years. And then we have a really good understanding of each part of the line, what is the situation there, and that's why we can assess this cost very precisely. So I'm coming to the results, and I see that the time is actually running. I'm going too much into details maybe with this algorithm. It's what's exciting myself maybe, but I try to come out from it and start maybe to have more this discussion and questions and answers.
Exactly. But maybe try to finish in the next 5 minutes so that we have at least 15 minutes left.
Yeah. So I directly go to the results. When those two big analyses are combined together, we will get the results as we can show it in e-Gridmap 2.0. So if you open any substation on this map, you actually get this precise information about the new capacities. And maybe I go to actually to the live, so it's better to show it there. And I think now it's time when you also can interact and ask some questions. So this is the live view of the e-Gridmap, and you can zoom in and find the exact location you are interested, or you can also, if you are not interested in doing any grid reinforcements, you just can drag this bar. For example, I want 10 megawatts of connection capacity, it's production side, and I want to do it this year. Okay, it's not realistic probably. Let's take next year. And then with the colored bubbles, it shows me where such possibility is available. So if I open, for example, substation, then it shows that actually 11.8 megawatt is possible to connect without any grid reinforcement. And starting from 11.8 megawatt, you have to do something. So if to read this table, you have, as I said, its maximum capacity is 100 megawatts, and it's for 110 kV substation. And here is the result of the network calculation and the cost analysis. So it's listed that the first breaking point is the first, and the capacity always increases. So you should read it that until 11.8 megawatts, I don't have to do anything. Starting from 11.8 megawatts until 20.6 megawatts, the additional cost is 3 million euros because of the transformer in Rakvere substation has overloaded. So maybe it's not, it's too big numbers. I will take something better. Okay, that's better one.
Oleg, we already have two questions.
Yeah. Yes.
Shall we ask them now?
Yeah, please ask. I think otherwise we will not have enough time for questions.
We have one question that concerns cross-border flows from Michael Berger. Michael, do you want to unmute yourself and ask Oleg directly, elaborate a bit, or is that not necessary? If you do want to ask it personally, just please unmute yourself and start your video quickly.
Yes, hello, this is Michael Berger. Well, maybe I missed it in the presentation, but I just wanted to know how do you consider cross-border flows in your calculation model? Yeah.
Mm-hmm. So the cross-border flows are considered or taken into account where we define the scenarios. We have 28 scenarios, and it's a combination of the load patterns, generation patterns, and also the exchange to the neighboring countries. So maximum export, maximum import. We combine these flows when we define these scenarios. So there are some scenarios without flows and some scenarios with external flows. This is how we take into account. Did it answer your question, or you want to ask something more specifically?
Yes. I just recognized. I mean, there's no market model behind your calculation, I guess. Mm-hmm.
Yeah, there is no market model. So this is based on the predefined scenarios. Of course, the scenarios are not, let's say, unrealistic. They are realistic. They take into account only the contractual loads, contractual generation, and also this export-import capabilities, NTC, what is actually there. So we don't exceed the limits of export or import. We stay within the bounds of the contracted values and the values what are available in the market.
Okay, thank you.
Thanks a lot, Oleg. We have another question that is about data and whether you make it openly available. We have Robbie Morrison here from the Open Energy Modeling Community. Robbie, do you want to ask your question yourself?
Sure. I'm interested in the data, but I was actually asking about the programming. I have a little bit of association with LF Energy, which is from the Linux Foundation, to bring together these kind of capabilities under an open source model, would the e-Grid consider making their source code open source?
I think it is even possible, but probably we would prefer some cooperation first between the transmission system operators. Maybe one problem about the code is that it is part of this code is in Python, so it is written especially concerning this Estonian grid model. So they run some specific contingencies, line, bus bar names, and so on. So it is the code is already designed for this certain database or model. So the code itself doesn't give you the option to expand it to other systems. So you need to actually take care of the database, the data structure, and rename in code also the source data. But I don't tell you right now that yes, we will open it, but I think I will definitely bring this question into our company and ask that there is interest if we can actually open this code to be available for everyone.
Great, thanks a lot. It sounds like Robbie is satisfied with that answer. We have another question on flexible connection conditions from, and now it's a bit of a struggle for me to pronounce this.
It's Hruvae. It's Hruvae.
Okay,
Yes.
great.
Thank
Already
you.
there. Perfect.
Thank you.
Question.
Yes, thank you. It's Hruvae from Croatian Energy Regulator. Yes, we are very interested for this flexible connection conditions agreement because so far it is not yet implemented in our country, but it could be one of the possibilities for the future. So my question is going into direction, could you maybe say, are these kind of contracts popular for new entrants, especially for the new producers? And can you maybe explain or elaborate what will happen in situation when you will have some specific contingencies in the grid and problems, and you will need to, let's say, lower the production of several producers? Do you have some internal rules? For example, what is the priority for decreasing of some specific producers in that case? Thank you.
Yes. Yes, we together with this flexible connection terms, we have also set these priorities, and basically it depends on the time of this agreement. The one who is first come, this will be limited as the last one. So if there are several connecting clients related to the same grid overloading, for example, and one has connected in 2019 and other has connected in 2020, then first the client who's connected 2020, latest client, will be limited first. And if this is not enough, then also the client who connected 2019 will be limited. So this is the priority. And limiting itself is done or should be available to be done through the control center. So from the new producers, we required the remote control functions, some certain functions, for example, all productions must have this secondary control available, so you can put any power set point that they need to follow. You must have option to activate the primary control, so they can support the frequency control, and also voltage control must be available to be controlled from the control center. So you put some certain reactive power value, or you put some certain voltage value, and then the producer is automatically following this reactive power according to the voltage set point. So this is done from the control center if it's necessary to be limited this producer.
Great, thank you.
Thanks a lot. We have another question that very much relates to what you just said. It's also on flexible conditions. Jano Auenbaum, do you want to ask your question?
Yeah, I can ask the question. I made a case, for example, the grid is already full and the new client wants a new connection and is willing to pay the additional connection costs. But on that part of the grid, you already have signed a flexible connection contract with another client, for example. What are the capacity conditions you are going to consider if you're calculating the new parameters for the grid? Do you sign a new contract with the flexible client, or what do you do? What are those?
Yeah, if there is already flexible client, then we don't touch this agreement. These conditions will remain the same. And for the new flexible customer, we find or we calculate these overloadings with the fixed value of this previous flexible client. Let me rephrase maybe that. For example, the previous client wanted to connect 10 megawatts, but we said that, okay, 5 megawatts you can get without any limitations, but from 5 to 10 megawatts, there is one line that might overload in some certain conditions. So this part is flexible for you, this 5 to 10. And when we are doing the calculations for the next client, we take into account this fixed part, 5 megawatts. So we put it into the model, and on top of that, the new client capacity will be added to the system and compared those two cases. And then whatever overloadings appear, they will be bounded with the connection agreement. And probably there are the same lines which will overload. And then it comes to operation, this priority thing, that the one who had the contract later, it will be limited in first hand. And if it's not enough, then we go to the one who had 5 megawatts fixed, and we can limit this guy from 10 to 5 megawatts.
Okay, thank you. Like this, I well understood, and the perfect answer to my question. Thanks.
Okay.
Great, thanks a lot. We have another question that is on whether you treat each application on its own, or you actually look at them together and explore synergies. It comes from Susanna Pato. Susanna, do you want to add something?
Hi, this is Susanna. I just wondered whether you take this project as they come in a sequence when they do the analysis, or do you think of clustering projects that want targeting the same location that could bring us more efficient outcomes, saying that that it's not only a 5 megawatt project is there, but within 1 year you collect 10 5 megawatt projects and you design the upgrade for that cluster of project, which would result in a lower cost for each of the participants. But it's a kind of a sequencing problem. So my question was whether you deal with this or you take the project one by one. Thank you.
Mm-hmm. Okay. In Elering, we have thought about it, and our process is like that. If there are several connections at the same time to the same substation, then those will be taken as a cluster. So we will sum up the capacity, and they are all together responsible of covering the costs to eliminate those additional investments. But if they are somewhere further aside, then we take each one as a separate project, and we don't cluster like bigger areas. But we have if they are coming not the same day, but after, for example, week or months, there is one customer coming and we will make agreement, then the calculations are recalculated, and the next client will have already a new condition. But yes, maybe answering your question, that if the clients are applying to the same spot in the grid or very close, then they are counted together. But if they are spread around, then we will not cluster them.
That sounds sensible. I think, Susanna, your question is answered. Yeah, sounds like it. We're almost out of time. I'm excited to see that so many people are interested in asking a lot of detailed questions. And thanks, Oleg, for the really, really interesting presentation. I also have a question myself that is maybe not as technical, but concerns the future of what might happen in terms of add-ons to the e-Gridmap. And do you think, because there's obviously a relation to spatial planning here, because you have a big map where you can see all the different connections in the entire country, and you calculate where the investment, where it's the best investment for a client to build new renewable generation. Could you also imagine in the future taking other things apart from cost into account, for example, environmental factors? Is that something that could actually fit with a tool like this?
Well, I think it's quite complicated for today, because the environmental impact, you mean by building new lines, or?
Exactly, when you think about spatial planning overall, and where new lines and new renewable generation would fit best, considering several factors, not just cost, but for example, the impact on the environment.
Well, I think this is done separately from the e-Gridmap, because this e-Gridmap is purely technical stuff that will give you the answers how it's electrically loaded, and the environmental thing will be looked separately. I'm not sure if it can be combined, and maybe I did not understand this combination really well.
Yeah, I think the idea comes because this is already a relatively detailed map that you can zoom into in all of the areas. And I was wondering if to this map, maybe you could add other factors, for example.
Ah, okay. Yeah, of course. This map can be added some additional information, some restriction areas, etc., etc. So I think this is a good idea, and this is currently this open source map. So probably we need to discuss regarding this proposal with our Ministry of Environment or whoever is handling those environmental restriction maps, that if we can use their data to add some layers to our map, and probably it's possible, and is giving some additional value.
Great, interesting.
Yeah, thank you for the idea.
Sure, you're very welcome. It looks like, oh, there's one more question that has come in. I'm looking to see whether we still have time to actually take it. Question about proposal from future producer to connect future plant directly to existing OHTL. Is it allowed, and how will it be calculated? Is this something that you can answer very quickly? Or is
yeah, I think the question is, can the client connect directly to the overhead line? That yes, it's possible. What will be in addition, the substation cost will be added then, because we need to keep this functionality and integrity of the grid. So we need to build the full substation with the line circuit breakers on both sides. So it's still possible to operate this line, and then the client connection points or base will be added. And there are some conditions also, that if the substation does not fit with the general social needs, like if it's only necessary for the client and it does not match with the general needs for the society, then there is possibility that this substation will be built only for this project with a certain deadline. So if the lifetime of this substation expires, then Elering is not responsible automatically to upgrade this substation, or to, yeah, you understand. So it's for 25 years or 30 years, for example, and that's it. If client wants to have another 30 years, then the client needs to pay for the substation.
Yeah, makes sense. We're already a bit over time, so thanks a lot, everyone, for sticking with us. We have more questions in the chat, but I think we cut it here. And Oleg, if people have additional questions, is it okay if they contact you after this webinar as well with their questions?
Yes, of course. Sure. And I think I will send my presentation to you after, and there is my email address, so you can mail me. Next week I'm going for Christmas holiday, so there might be some bigger gap where I don't read work emails, so I might delay with the answer, but I try to answer as quickly as I can.
Great, that sounds good. Yeah, and I think all of us can understand taking a bit of a break over Christmas. That also answers the final question that we have in the chat. Will the slides of the presentation be available? Yes, you will receive them. Mm-hmm. And we will also put this recording on our website, so you will be able to go back to the discussion if you're interested to in the future, or recommend it to a colleague who maybe hasn't joined today but could benefit from seeing this. Yeah, and I hope that all of you have benefited from this interesting discussion and this interesting presentation. Oleg, thanks again a lot. I really enjoyed this. Yeah, and I think it has been a very worthy addition to our series of best practice webinars. I want to leave you all with wishing you very happy holidays. And I hope to welcome many of you back in a future best practice webinar.
Yeah, thank you very much also from my side, and have a really nice and happy Christmas time. And I hope we will see you with some of you by discussing in emails. And I hope that this kind of approach will go to other TSOs as well, and actually this kind of approach could be taken into operation in other TSOs as well. Thank you very much from my side.
Thanks a lot. And that's always the hope, that others take something from it, replicate it, work together with you on maybe using it in their own countries. So thanks a lot again, and hopefully see many of you soon. Bye-bye.
Bye.
Thanks very much.